Welcome back, mathematicians. We are now on to section 3.9, which is about inverse trig functions and their derivatives. So I first kind of wanted to have a little review of inverse trig functions and kind of give you guys some visual representations. So you can see I've already drawn a few of them. And just so you can kind of get a feel and just kind of be more aware of how these functions work and what they look like and some of their relations. So the first two here that we have are, we say it's like sine inverse or arc sine. I think we've mentioned this already, that this is not the same as like 1 over sine. That's cosecant, excuse me. So I usually like to do arc sine just to kind of help me remember that it's different than like 1 over sine. So we can see that sine, I can only put in numbers between -1 and 1, and its outputs are going to be between negative pi over 2 and pi over 2. All right. So cosine inverse, also known as arc cosine, I can also only put in numbers between -1 and 1, and it's actually going to give me numbers out between 0 and pi. If you remember the trick to remember positive and negative quadrants, sine is positive from 0 to pi, so I need somehow to get negative outputs for arc sine, so I moved its outputs to pi over 2 and negative pi over 2. Cosine, on the other hand, can give me a positive output for putting it in between 0 and pi over 2, and negative for pi over 2 to pi. So that's the reason that cosine is going to go from 0 to pi, and that's why they're a little switched. So we can also use what we learned about shifting and translating functions. So if I can find it, we can see that cosine inverse of x is the same as pi over 2 minus sine inverse of x. You could also put arc sines. Okay? Notice arc sine is also symmetric over the origin. So say like negative sine inverse of x will equal sine inverse of negative x. Alrighty? So let's go look at arctan and arccotan. So arccotan is also symmetric about the origin. Also making it an odd function, similar to sine, so we can say like tan inverse of negative x will equal negative tan inverse of just x. Alrighty. Arctangent, excuse me, I can input any number, but it's only going to give me numbers out between negative pi over 2 and pi over 2, just like sine. Okay? These gray lines I've drawn here are horizontal asymptotes. So arctan is never going to achieve pi over 2 and negative pi over 2, but it's going to come very closely as we go off into the horizons. So cotangent, arccotangent, is also going to have asymptotes at pi and at 0. I didn't draw the one at 0 because I wanted you to see the axes. And similar to cosine, I forgot the S right there, cotan inverse, we can see by looking at our graphs that it's also scaled the same way cosine is, arccosine. By that, it's pi over 2 minus tan inverse of x, or arctan. Okay? So for arctan, I can put in any number. I'm just going to approach pi and 0. I can never actually put out those numbers. Alrighty? So the next pair are arcsecant and arccosecant. These are pretty interesting. Arcsecant has a horizontal asymptote at pi over 2. And, oopsies, we can see that it does achieve, that's a closed hole at 1 and at -1. And for arc cosecant, same thing. Those are closed holes. So if I plug in 1, I'm going to get pi over 2. If I plug in -1, I'm going to get negative pi over 2. Alrighty. Similar to arc cotangent and arc cosine, arc cosecant, we'll call it cosecant inverse, is also going to equal pi over 2 minus secant inverse of x. Alrighty, so these derivatives are pretty funky looking, so I want to show you the derivations for all of them. Alrighty. So we're going to do arc sine first. So let's let f of x equal sine. And we're going to use that derivative of the inverse function, the formula from the last section. So f of x is going to equal sine of x. That means f prime of x is going to equal cosine of x. And f inverse of x is, let's call it sine inverse instead of arc sine. I think that'll help. Okay, cool. And we don't know the derivative of arc sine yet. We're trying to figure that out. So first I want to bring up this Pythagorean identity, that cosine squared u plus sine squared u equals 1. Should be like your favorite one. We're going to use that. So f inverse prime equals 1 over f prime of f inverse of x. Okay? So that means that sine inverse of x prime will equal 1 over f prime of x is cosine, so it's going to be cosine of f inverse of x. So it's going to be cosine of sine inverse of x. Well, that's pretty gross. I really don't have to do that. I also really don't feel like every time I put an x, finding sine's inverse and then plugging that into cosine. That seems like a lot of work. So we can take this and simplify it even more. And we're going to use that using the cosine squared u plus sine squared u. So I have just a cosine here, cosine to the first power. So let me try to get this all equal to just cosine to some first power, not squared. So I'm going to subtract sine squared onto both sides. So we have 1 minus sine squared of u. And then I'm take the square root of both sides. All right, cool. And we're actually just going to take the positive version of that because of how arcsine looks like. Alrighty? And we'll get to that in 1 second. So I'm now going to plug in for where we started in black, or where we ended. So 1 over, instead of cosine of sine inverses are u in this case, I'm going to have the square root of 1 minus sine squared of sine inverse of u. Not u, x. Let's extend this a little bit. Oh, apparently I'm hungry. Okay. So how can I simplify this? So sine of sine inverse will just give me x, and that squared is saying that I have 2 of those. So I can rewrite it, and I'm going to, just because it's going to make it a little clearer. 1 minus sine of sine inverse squared. So this inside sine of sine inverse of x, that's just going to be x. 1 divided by, okay, these don't need to be this big anymore. 1 minus x squared. Alrighty, and remember how for arc sine, x could only give us something outputting between 1 and -1. That works for here too. So we say that absolute value of x is going to be less than 1. Alrighty, so that gives us the following rule. I think we're on to 18 now. So the derivative with respect to x of sine inverse equals 1 root out of x. All derivative rules now have u's. 1 over the square root of 1 minus u squared times du dx. If you don't like writing du dx, just write u prime. Just as long as you know it's the inside derivative with respect to the variable. Alrighty, so let's now move on to secant. So we're gonna let f of x equal, oh, not secant. That one's a tricky one. Let's do tangent. Tangent of x, we know that one's derivative is secant squared x, and the inverse is tan inverse, or arctan. So we had, I'd given you cosine squared u plus sine squared u equal to 1. There's actually 2 other Pythagorean identities, and I'm going to use the one where I get tangent and secant. So I'm actually going to divide everything by cosine squared of u, because I really want this other identity. So cosine squared of u over cosine squared of u is going to give me 1 plus tangent square u equal to secant squared u. Alrighty? Remember that, we're going to use it. So now we're going to find the derivative. So s inverse prime of x is going to be 1 divided by f prime of f inverse. We love composition functions. So we're going to have 1 divided by f prime, remember, is secant squared. So we're going to have secant squared of f prime of x. I'm sorry, f inverse of x. So we have secant squared of arctan. And using this Pythagorean identity, I'm already given. I don't have to rearrange like I did last time. So secant squared of u, it's going to be 1 plus tangent squared of u. So I'll have 1 plus tangent squared of tan inverse of x. And I know from last time, when I was doing arcsines derivative, tangent squared of tan inverse is going to give me, tan inverse of x, that's just going to give me x squared. It's going to have 1 plus x squared. Alrighty? So that gives us the derivative rule 19. The derivative arctan of u with respect to x is going to be 1 over 1 plus u squared times du dx. And if you're thinking, well, why don't we do cosine and cotangents? It's because I'll show you in a little bit and it has to do with that shifting that we did earlier. So now we're going to do secant. Secant is a little tricky. Not tricky. It just has a few more steps. So we're going to make f of x secant of x. We know that its derivative is secant x tan x, and its inverse is arcsecant. Righty. So the derivative of the inverse, 1 over the derivative original of the inverse. There we go. So we're going to have 1 over secant of the inverse function times tangent of the inverse function. Remember, these are not times. These are functions that I plug in, put an input, and I get an output. 1 over secant inverse of x times tangent secant inverse of x. I just like blanked. Okay, let's extend this. No, I don't like that. Okay, I do want this 1 to be centered. Okie dokie. So secant of secant inverse of x, well, that's just going to be x. This tangent's going to cause me a little bit more trouble. So I know I have an x here, and I'm also going to have, well, tangent equals 1 plus tangent squared of u equals secant squared of u. So let's do some maneuvering. So we had 1 plus tangent. Alrighty, so that's going to give me, subtract 1 on both sides. Minus 1, and I'm take the square root. I want to write that a little nicer. So earlier we didn't, we only kept just the plus or minus, but this time we're actually going to have a plus or minus. Alrighty. So let's go back to ready in black. So we talked about secant inverse of x. That's just going to give me x times plus or minus the square root of secant squared secant inverse of x minus 1. None of these lines are long enough. which will give me plus or minus x times the square root of x squared minus 1. Alrighty, so to deal with this plus or minus x, the minus actually only comes out when x is negative, and the positive comes out when x is positive. So I can write it like this. When x is greater than 0. Alrighty, and kind of see if we just kind of look at it's positive when x is already positive, and it's a negative when x is negative. So if x is a negative, that's going to make the outcome positive. So we're actually going to rewrite this as 1 over the absolute value of x times the square root of x squared plus 1. Remember that square root can never give me a negative number. So the only thing that's changing is this x in the denominator by itself. And since we can't ever have a negative under that radical, that's also going to make x, absolute value of x, needs to be greater than 1, which we can kind of see already from when we were looking at those graphs earlier. So what is this, 19, 20? So that gives us our next derivative rule, that the derivative of the inverse of secant is 1 divided by the absolute value of x, square root x squared, minus 1. And I'm actually going to go back here because I somehow started to do plus 1s. And that is not cool. Right? Okay, yeah. I had negative 1s earlier. Okay, great. And again, oh no. I'm just really liking writing things in x, and they need to be in u. Alrighty. And in this case, the absolute value of u is greater than 1. Alrighty? So if we remember from earlier, arc cosine of x is just pi over 2 minus arc sine of x. Cotangent, arc cotangent is pi over 2 minus arc tangent of x. And finally, arc cosecant of x is pi over 2 minus arc secant. Well, pi over 2 is just a number. So I know arc sine, arc tangent, and arc secant's derivatives now, I can apply that to all these cos, arc cotangent, arc cosine, arc cosecant, and I can find a derivative really easily. So we're going to get the derivative with respect to x of cosine inverse of u is negative 1 over the square root of 1 minus u squared. So the negative version of sine, arc sine. And remember, the absolute value of u needs to be less than 1. The derivative with respect to x of cotan inverse of u is going to equal negative 1 over 1 plus u squared. And the derivative of arc cosecant of u is negative 1 over the absolute value of u times the square root of u squared minus 1, when the absolute value is greater than 1. Alrighty? And those are the 6 inverse trig functions. If it's what I call a co-function, so cosine, cotangent, cosecant, the inverse derivatives are all negative. If it has an s with it, so secant, sine, arcsecant, arcsine, arccosine, arccosecant, so anything but the cotangent and tangent, you're going to have a square root and a subtraction. So those s's. So I have a subtraction and a square root. So that's going to tell me I'm going to have sine and cosine. This one has a square root and a subtraction, so it's cosecant and secant, depending on the will give you a negative. All right, so those are just little ways to remember it. So let's crank through some examples and we'll be done. So this one is in your textbook, 3.9.33, and we're given that y equals ln of arctan, and we're going to find y prime. Alrighty, so this is chain rule, right? I have a function inside my other function. In this case, tangent is my inside function. Sorry, arctangent, and ln is my outside function. So I'm going to take the derivative of the outside with the inside still the same. Ln of whatever is going to be 1 over whatever. So I'm going to have 1 over tan inverse of x times the derivative of my inside. Alrighty, so I'm not going to touch 1 over arctan, and I'm now looking for its derivative, which I know is 1 over 1 plus x squared. And we're done. If you wanted to, you could rewrite it as 1 over arctan of x times 1 plus x squared, but it's all the same. Alrighty? So we'll do one more example. And this is 3.9.36. And we're given that y equals cosine inverse e to the negative t. And you guessed it, we're going to find y prime. Okay, so my outside function is cosine inverse, and my inside function is e to the negative t. So y prime, I'm going to do cosine inverse's derivative, which I know up here is negative 1 divided by square root of 1 minus u squared. And why did no one tell me I'm missing all of my du over dx's? No one told me. My gosh. Okay, you're not allowed to ever forget those. So I'm going to have negative 1 over the square root of 1 minus, I don't have an x, I have e to the negative t squared times the derivative with respect to t, that's my variable, e to the negative t. So e to the t's derivative, e to the negative t's derivative is going to be e to the negative t times negative 1, the derivative of negative t. It's kind of like a triple chain rule. So we're still going to have 1 over 1 minus e to the, I'm going to simplify that and make that negative 2t. Those guys are going to multiply times e to the negative t times negative t's derivative, which is negative 1. And then I can simplify. So this negative times a negative, those are going to cancel out. And I'm going to have e to the negative t divided by the square root of 1 minus e to the negative 2t. And then if I wanted to, I could simplify one more time because that is an e to the negative t, and I'll just get 1 over e to the positive t, because I moved it down. And voila, and we're done. So that concludes 3.9, and I will see you guys tomorrow. Goodbye.